Now we're going to do some application. So find two numbers whose sum is 18. Well, let me back up. In all these story problems, the answer is going to be the vertex. And so sometimes I'll use the word minimum, sometimes maximum. If the parabola opens up, meaning it's a positive x squared, it would say minimum. And if the parabola opens down, which is negative x squared, it'll say maximum. But either way, the minimum or the maximum is just the vertex, right? So find two numbers whose sum is 18. So sometimes we can figure this out by just like listing numbers that add up to 18, like 9 and 9 and 10 and 8 and 11 and 7 and 12 and 6, and there's a lot of numbers, right? And they want to know which of the pairs of numbers that add up to 18 has the highest product. So the product of 9 and 9 is, not 18, product is 81. Product here is 80, 77, 72. Which one is the highest? Well, you can probably guess it's 9 and 9. But we really need a system, right, for doing it. So what we're going to call x is the first number. How can I express the second number if the two numbers add up to 18? Right, 18 minus x. And then the product is going to be y. So y is equal to x times 18 minus x. So if I distribute that and put it in standard form, that was a minus. And then I'm going to factor out a negative, x squared minus 18x, and leave a blank. Half the middle term squared here is 81, but it was really a negative 81. And then when I move it over, it's a positive 81. So y equals the negative of x minus 9 squared plus 81. So, and you'll see on the homework, I'll say, well, then what does that mean the vertex is? And the vertex would be 981. Remember, the vertex is x and y, and x is the first number. So the first number is x, which is 9. Second number is 18 minus x. 18 minus 9 is 9. And then the product is 81. But I just said find the numbers, so like those two are the answer. Even if we can figure it out by hand, we're still going to write the equations. Find two numbers whose difference is 10. So difference is 10 would be like 12 and 2, or 11 and 1, or 15 and 5, just kind of randomly coming up with numbers. And this time they want the product to be a minimum. So here the product is 24 or 22 or 75, right? It's hard to say like which one's the smallest without going through a lot more combinations. So here I'm going to, again, let x be the first number. Difference is 10. Now, it's up to you what one you're thinking of the first number, what one you're thinking is the second number. It's easiest if you think of the lower number as being the first number, because then you can express the higher number as x plus 10. Alternately, you could express the higher number as x and then 10 minus x, or sorry, x minus 10. But then that gets confusing, I think, with the sum, so I like to use x plus 10. And then the product is a minimum, so the product is x times x plus 10, or x squared plus 10x. You'll leave your blank, half the middle term squared, 25, 25, move over the 25. So I'm going to get x plus 5 quantity squared minus 25. And there's points, by the way, for each of these things. So like there'll be a point for like identifying the variables, a point for your original equation, point for your changed equation. And then your vertex here is negative 5, negative 25, x and y. So the first number is negative 5, and then the second number is negative 5 plus 10, which is 5. And the product of negative 25 is the lowest product. So it's negative 5 and 5 are the two numbers. So those are like number problems. And then we have fencing problems. So you have 120 feet of fence and you're making a rectangular pen or whatever, garden. And so we have length and width, right? So x is equal to, let's call it the width. It doesn't matter if you call it the width or the length. How can I express the length if I have 120 feet to go all the way around? A lot of people say 120 minus 2x, but remember that you've got to divide that by 2. So each length here is going to be 60 minus x. 60 minus x. And if you add all four of those up, you'd get 120. So again, area is base times height, or length times width. If I put that in standard form, negative x squared plus 60x, I'm going to factor out a negative x squared minus 60x, give my blanks, half the middle term squared, 900, which is negative 900, which when we add it becomes positive 900. So my final equation is negative x minus 30 squared plus 900. So my vertex is 30, 900, x, y. So that means that the width is x, which is 30, and I guess it's feet. And then the length is 60 minus 30, also 30. And that should kind of make sense, that the biggest rectangle you can make is a square. Next one is also a fencing problem, but it's a little bit different because you're only going to use 3 sides. It says you have 40 feet of fencing, but you use your house as one side. So you only need to put fence on 3 sides. So then if we have x be the width, how can we represent the length? Right, it's going to be 40 minus 2x. Do not need to divide it by 2 because I'm using the house as the other side. So y is equal to x times 40 minus 2x. So a lot of people still ask me, like, how do you know if you divide by 2 or not? It's if you're using all 4 sides, right? Using all 4 sides, you divide by 2. If you're only using 3 sides, then you don't. Half the middle term squared, so that's 100, which is really a negative 200, which when I pull it over is a positive 200. So y equals negative 2x minus 10 squared plus 200. So my vertex here is 10, 200. So the width is 10. I guess it's feet. And then the length is 40 minus 2 times 10, or 20 feet. Perfect. The next ones are what I call people money questions. And so in people money questions, as the people increase, the money decreases. Actually, it's the other way around. As the money increases, as the money goes up, the people go down. They're inversely related. So this is talking about, 300 passengers a day, $8 a person. So you have like your people and you have your money. And you don't have to even write this down. This is just kind of understanding the problem. So if we have 300 people and each person is charged $8, how much money do we make is $2,400. Then it says 20 passengers will be lost for each dollar increase in the fare. So you can charge $9, but then you're only going to have 280 people. And 280 times 9 is 0, 2, carry the 7, 25.20. But you're like, hey, I still made more money. What if I charge $10? If I charge $10, then 20 less people. So now I got 2,600. Well, what if I charge 11? What if I charge 12? Am I going to keep making more and more and more and more money forever? Or eventually, will I kind of reach like a top and then I'm charging so much that not enough people are coming that overall I'm making less money? So the problem becomes money going up, so it's and people going down. So $8 would go up by $1, and then the 300 people would go down by 20 people. And X is that number of times the price is increased. So if I FOIL that out, 2,400 minus 160x plus 300x minus 20x squared, negative 20x squared plus 180x plus 2,400. And I could divide, oh, no, I can't. Oh, good point. If it was equal to 0, I could divide everything by negative 20, but it's not. It's equal to y. I have to factor out a negative 20. X squared minus 9x, leave the blank. Half the middle term squared, half of 9 is 9 halves. 9 halves squared is 81 fourths. If I multiply 81 fourths times 20, I'm going to get negative 405. I'm doing that in my head. Yeah, negative 405, which then will get added to both sides. Let me just check that. So 81, so it's 81 times 5, yeah. So then I have y equals negative 20 x minus 9/2 squared plus 2805. So that's my equation. Now my xy turns out to be my vertex, 9/2 comma 2805. And 9/2 is your x. So I have 4.5 $1 increases. If I started off at $8 and I have 4.5 $1 increases, what's my new price? Well, it's $4.50 plus $8, so it's $12.50. I'm just going to write it big here, real big. So $12.50. Yep. And then the total you would make is that 2805. Perfect. I'm going to flip to here. I don't always do this one here, but I'm just going to add it in. I'm not sure if I've kept it in the notes, but it's that classic, like, what time does the rock reach the ground question, where you replace the h with 0. So we did the same problem when we did roots, right? Because where it touches the ground is where the roots are. So if I divide by negative 5, 0 equals t squared minus 5t minus 6. So 0 equals t minus 6, t plus 1. So t equals 6 and t equals negative 1. Right? What time, that's old. What time does the rock reach the maximum height? So the maximum height is taking h equals negative 5t squared plus 25t plus 30 and changing the form to vertex form. So factoring out a negative 5t squared minus 5t plus 30, half the middle term squared is 5/2 squared is 25/4. If I multiply that, what do I get? Negative 125/4. So I've got to add that to both sides. So I get h equals negative 5t minus 5/2 squared plus 120, I don't know, 245/4. So what time does it reach the height? Like, those are my vertex coordinates, right? And you could do those as decimals if you want. The time that it reaches is the 2.5 seconds, because the x is time. And then the actual height is the 245/4. Whatever that turns out to be as a decimal is fine too. The last one is, what time does the ball reach a height of 50? So if you want the height to be 50, it's kind of like the first one, where the first one was, when does it reach the ground? The height was 0. Now, when does it reach a height of 50? We replace h with 50. Which, by the way, why does it have two answers? Why does the ball hit the height of 50 2 times? Right, once on the way up and once on the way down. Now I can do this divide by 5, because it's set equal to 0. Right? It's an equation not equal to h anymore, but equal to 0. And if I factor this, now I get two answers, 1 second and 4 seconds. And this should make sense because it hits the time, like that height, just like ballparking here, 50, once on the way up and then once on the way down. So it would hit it at 1 second, so like 1 comma 50, again at 4 seconds, 4 comma 50, and then I had the 5.5, like the 2.5 over here for the vertex, 2.5 comma whatever 245/4 is for that. So this question really pulls the whole thing together. Okay, so applications of quadratics.